Hydrogen is a clean fuel. It is an energy carrier that can be used for a broad range of applications. These qualities make it an attractive fuel option for transportation and electricity generation applications. Hydrogen is an energy carrier that can be used to store, move, and deliver energy produced from other sources. When burning, it generates energy in the form of heat, with water as a byproduct, generating no atmosphere-warming carbon dioxide. But creating hydrogen and transforming it into a useful format requires energy, and that energy is not necessarily renewable. Many critics say the hydrogen industry will wait for oil and gas giants to stall the adoption of pure renewable energy sources like solar and wind, giving them a green cover. Four main methods to produce hydrogen fuel: thermal, electrolytic, solar-driven, biological. Thermal process system. Thermal processes for hydrogen production typically involve steam reforming, a high-temperature process in which steam reacts with a hydrocarbon fuel to produce hydrogen. Many hydrocarbon fuels can be reformed to produce hydrogen, including natural gas, diesel and others. Electrolytic process system. Water can be separated into oxygen and hydrogen through a process. Electrolytic processes take place in an electrolyzer. Solar-driven process system. Use light as the agent for hydrogen production. There are a few solar-driven processes, including photobiological, photoelectrochemical, and solar thermochemical. Photobiological processes use the natural photosynthetic activity of bacteria and green algae to produce hydrogen. Photoelectrochemical processes use specialized semiconductors to separate water into hydrogen and oxygen. Solar thermochemical hydrogen production uses concentrated solar power to drive water-splitting reactions, often along with other species such as metal oxides. Biological process system. Biological processes use microbes such as bacteria and microalgae who can produce hydrogen through biological reactions. Main types of hydrogen products: green, blue, and gray. Other minor types of hydrogen: pink, yellow, and turquoise. Pink hydrogen is made with electrolysis powered by nuclear energy, which does not produce any carbon dioxide emissions. Yellow hydrogen is made with electrolysis from the energy grid. The carbon emissions vary greatly depending on the sources powering the grid. Turquoise hydrogen is produced from methane pyrolysis or splitting methane into hydrogen and solid carbon with heat in reactors or blast furnaces. Advantages: numerous sources, efficiency, sustainability, powering spaceships. Hydrogen can be produced either on-site where it will be used or centrally and then distributed. Hydrogen is an efficient energy type since it has the ability to convey a lot of energy for every pound of fuel compared to diesel or gas. Provides a sustainable system independent of petroleum products and is also non-polluting, producing no emission. Hydrogen energy's efficiency and power make it an ideal fuel source for spaceships. Its power is so high that it's able to quickly rocket spaceships to exploration missions. Disadvantages: expense, safety, fossil fuel dependency, and storage. Electrolysis and steam reforming, the two main processes of hydrogen extraction, are extremely expensive, costing about $6 for 1 kilogram of hydrogen gas. Hydrogen is a highly flammable and volatile substance that frequently makes headlines for its potential dangers. It is renewable and has a minimal environmental impact, but its separation from oxygen requires other non-renewable sources such as coal, oil, and natural gas. Due to having a low density, it has to be compressed to a liquid state and stored the same way at lower temperatures to guarantee its effectiveness and efficiency as an energy source.